Hello everyone, I hope you are doing good. In the previous video, as is showing on the screen, we have done about stack using array. I have done the code. I hope you got the basic concept. If you did not find it helpful, means with the help of array, it's nothing bad because we want it to be done by linked list. That is my priority. Of course, you may be liking why doing array. It is very simple in array, and in the linked list you know that we need to use pointers and all, but I prefer using linked list because it gives us flexibility. It's dynamic in nature and this is static, means we can't change the value of this, we can't increase or decrease the value, it need to be static. So today we'll be doing using linked list, but before that I want that you should know the concept of stack. Means what is stack, I already showed you with the help of figure. Okay, let me show one more time the figure. So this was the figure I explained in the previous video. Watch the previous video to understand this figure very clearly. So this is a very good clarity figure, so you can see this figure. I'll put the figure also in GitHub, you can access it from GitHub. So let's do today with the help of linked list. So let me comment out this. I'll do both the code in the same file so that you can compare between them and you can choose your own. So let's go here, let's come down here, go till endman and just comment out this. So here you can see that I printed out some code, and let me uncomment them and put this under. Okay, this is stack using linked list. So let's run this and see what we are getting. So we can see the stack using single linked list. So that is what we will be doing today. So let me see one by one the line that I have written here. So these two lines need no introduction if you followed till now. Okay, now this line also need, this class also need no introduction if you already are familiar with my linked list lectures. If you saw my linked list lecture, then you know that this is the line I use in every linked list, because I want that you should be comfortable using the same thing. By changing you may be confused, but using the same thing you'll not be confused and understand in a better way. And in the endpoint there is nothing, just saying that stack using single linked list. So let's start coding and we'll do by doing linked list. So before this I want that you should know the concept of linked list, because linked list is knowing is very important to understand this. So okay, let me say one more line if you don't understand what this node is. So in a linked list we have many nodes connected, that's the name, it comes in linked list. And here we are using data is just a data member of this node, and there is a node called next. Because you are using single linked list, you know in single linked list there is only next, no previous, while in double linked list there is also one new node called previous. And here we added a friend class linked list because we will be adding one more class called linked list. So we are adding friends so they get access to these private members. So if you are feeling a little bit difficult to understand this, watch the linked list series of single, double and circular linked list, you'll understand the basic more clearly. Now let's start. We'll create a class called linked list. Linked list, and this is the class created. So you can see that this is the friend of this class, means it have access to both of this. So first we'll create in the private, we'll create a node. We'll just write node and we'll write head. We'll create a node called head because this will see our stack's head. You know that in a head, the top, this is the head in linked list, this is the top. In, you can see in array it's the top, and in the linked list you can say this is the head. When first element is added, this will become the head. Okay, let me remove everything from here. So erase all link. Okay, first time this will become the head, then this, and slowly by slowly our head will become the one that is added in the last, and the first added will become the last element, which will be pointing to the null in the next. So I hope you're getting this concept. So now let's go back here and come down here. So we'll create a node, and now let's come to the public. We'll in the public, let's write public because we want that the function we are adding now should be accessible to everyone, so we are making it public. So first of all we'll create a constructor of this linked list. We'll just write linked list. You know already how to create a constructor. We'll just write, and we'll put the value of head is equals to null, because we want that whenever instance of linked list is created, the head in the first should print to null, so that no any garbage value is inside the head. Secondly, we need to add element inside stack. You know that in stack the element is entered in the head, means whatever the last element is the first output. So in linked list I already taught you how to put in the head, how to put in random position, how to put at the end. So in stack you not know all the condition, just you need the condition how to add in the head. So we'll write void, and as in the previous video also I said, here we have three push, pop and display. So we'll write push because we want to push an element, and we'll write here new data. Why is new? Why we are putting this data? Because we know that we need to enter a data in this node. So we'll enter the node so that you can see the example more clearly. You can add anything in it. We are adding a data. Okay. Now inside the push, we'll create a new node. We'll just write node and we'll create a new node with dynamic memory allocation of type node. So we created a new node of type node. So if you're not getting this, that means you did not watch the previous video of linked list. Watch the linked list full series, then you'll understand this in a better way. So I did this. Now let's add data to this new node. New node and the data is equals to new data. So now inside this new node data, we are adding the data that will be passed by using push, and we want that the new node in the next should point to the head. Okay, the new node, because we want that whatever the new node is added, it should point to the next to the head, because we want that this should be the head. New node should be the head. Now if our head is not null, suppose if our head is not null, then what should be done? If our head is equals to null, if our head is equals to null, then what should be done? If our head is null, we want that head should be equals to new node. The new node passed should become the current head. Or else if there is already an element inside the stack, means there is already some items, then we want that the head should be equals to the new node, means the new node should be equals to the head. Previously because when we add elements, we may add in the next, but we don't want to add in the next. We want to be the whatever the new node that we created should be in the head. So this will be the head for this node. I explained this very well using single and double linked list. You can watch it from there. Now we need to display it. For displaying, we'll just write void and display. In the display, we'll just write while our head is not equals to null. If our head is not equals to null, just print out what is inside the head. So we'll just write print out cout head data, means whatever is inside the head, just print out all of this if until the head is not null. You know that when after the head in the end in the next it points to null. So we'll write cout head and we'll just be going till head is equals to head next, because we need to add a condition so that we get a false once it reaches the null. So because we want this while loop to end, or else it will just go on infinite. So this is our while loop. Now we'll add some element inside this linked list. So we'll just first call the linked list and we'll add a node. You can name it anything. I'll name it node 1 because we used in the previous, while learning node I use this so that we don't become confusing. So now we'll add some members. So we'll write node 1 dot push and 1, means we are entering 1. Then next time we'll write node and node 1 dot push 2, and the third will write node 1 dot push 3. We'll add one more, node 1 dot push and 4. That is it. We'll add only 4 members. We can add any type, how much you want, it's up to you. So you can add anything whatever you want. So there is, now we want to print out. So we'll just write node 1 dot display. Let's come here, just let's run this. You can see it is printing 4321. You already know why it is 4321, because it's in the stack. In stack, you know, whatever the element is entered in the last, this will become the new head. So 4 is printed first, then the 3, then 2, then 1. Because you know that in stack the last element is the first input. I already wrote in the figure, last input is the first output. So 1 2 3 4, the 4 was the last input, so it will print out in the first. So that is the concept used here. Now in the stack we have one more concept. We need to delete and the deletion should start from the here left. First 4 will be deleted, then 3, then 2, then 1. So let's call one more function. Let's come down here and just write. Okay, before writing all the function, let me put a comment here so you know adding elements. Okay, and here we'll write displaying elements. Now before displaying elements, now we'll write here deleting elements. So in the deleting, we'll call a function called void, and we'll name it delete. Okay, we'll not name it delete because deletion operator, it may give some error. So we'll delete something and come down here. You know that in stack the deletion should start only the first one should be deleted, then the second one, then the third one, then the fourth one. I mean, the deletion should start from the head. So we'll just write, we'll create a node called temporary and we'll give access to the head. And I already said you while teaching linked list, I already said if you give access to the head, this temp will have access to all the node that is in this linked list. So if you get access to the head, you get access to all the nodes. So we'll write once more and we'll write head equals to temp next. So now after this line, we are calling once more time the head, and now the head will be the next element to the temporary node. And what is the temporary node? Temporary node is the head. Suppose, let me give you an example. If it is 1, 2, 3. So currently temporary is giving the head. So this is the 1 is the temporary value. Okay, let me come down here and write 1 is the temp now. Okay, let's give some spaces more so that you understand in a clear way. Just giving an example if you are facing any difficulty. Now currently we wrote here temp is equals to head. Means now 1 is accessible by temp. And what is temp next? Temp next is 2. This is our temp next because it is after the temp. Now we want that temp next should be equals to head. So if you come down here and we want that this should be the head. Previously you know that this was the head, and I'll write it previous. So let me come here, previous head, and this we want it to be current head. So previously this was the head and we initialize it to temp, you can see here, and now we want that head should be equal to the temp next, means this should be our current head. And there is one more function in C++, I said you, we can just free something, we can just free temp. If you're not understanding this, I highly recommend you to watch linked list, double linked list, circular linked list. You will understand all the basic concept, and it's very necessary because there are some lines that if you watch it for first time, it's like bouncer going above the head. So you need to watch it. So this is only the 3 lines that to be added, but in a linked list we added some more lines because we need some more concept. But here this is the only concept. We just need to delete the first element that is entered in the last. Okay, now if you save this and run this one more time, you can see same thing is getting printed. Why? Because we did not call the delete function. Suppose now we call here node1 dot delete, and if you just run this, you can see here earlier it was printing 4 3 2 1, but now it's printing just 3 2 1. So that is how our stack works. It prints out in the opposite order. The last input will be the first output, and while removing, the last one will be removed first. So I hope you got the concept. So let me print out this one more time in the top so that you understand in the better way. So let's print out first without deleting anything, and second by deleting. Okay, this, let me write something. Okay, before delete and after delete. Okay, let's write here, let's call this function here one more time, Control C, and we'll write here cout. This is just for understanding, there is no record for anything. Before delete, just you can, so that you can understand in a better way. Okay, and here we'll just write after delete. After delete, and we'll just put end here. So now you can see it more clearly. So just let's comment out this, because I see that my display don't run if I call it 2 times. If you know how to solve this, please comment out. I highly recommend it. Okay, if you want to know that what I mean to say, you can see here. Okay, I'll try to write one more time. And if I run this, you can see before delete is getting, but after delete is not getting printed. So this is the thing I want. I'm not finding how to solve this problem. If any one of you know, please try to recommend me how to display one more time. I'm not able to display it one more time. So let's just comment out this not Windows display, and it will work totally fine after this. So we'll write control, run one more time. Okay, there is some mess going on, and let me do one more time before display and just run this. Okay, before display got printed. Now we need to just comment out this line and call after display. Okay, now you can see this is the base concept. Before display, you can see the 4321 is getting printed in the right hand side, and you can see after delete the 4 is getting removed because this was the last element added. You can see the last element added is 4. Now let's go one more time to the code so that you understand better. So first I called a class node in which we gave an integer type of data and a node pointing to the next. This is a pointer which will point to the next node. We gave a friend class because we want that linked list should have access all of this private member. If you write a structure, then we need not add this friend class, because inside the structure whatever is there, it is direct public in nature and by default, and in class it is private in nature by default. In the linked list we added one more node called head, because we want that this head should be the first element created in a node in a linked list, and we want that at first it should point to null because we don't want any garbage value. And while adding element, we created a new node of type node, and in the data we wrote this, and in the next we want that this new node should points to head, because we want that this new node should become the current head. You can see here. And if the head is null, we want that this new node should become the head at first, because you know the head in the first is null. Okay, next to delete, we created a temporary node and we gave access to the head, and you know that if you get access to the head, you get access to all the node. And the next we wrote that head is equals to temp next, means whatever is in the head next to head will become the current head, because we are going to free up the present head, the head that the node is having access. And the displaying we wrote that if our head is not null, you know that the head will be null in the next at the end. So if it is not null, just go on, just print out all the element that is in the head. So that is it, and we just called out this function just for doing the functionality, and I asked you to help me solve this problem of calling a node 2 times. So that is it for learning stack using linked list. I hope you got the basic concept. It is very easy if you have little bit concept of linked list, and if you want the concept you can watch my previous video.